All right, so for problem number 8, we did a version of this on the first practice test, so I'll move a little bit quicker through this, but not much. All right, so 60 is the speed it launches at, 60 meters per second, and the angle is 65 degrees. Now let's go ahead and get the x and y components of this velocity vector that we're launching at. So 60 at an angle of 35 degrees gives us, again, so this is, sorry, let me just write this out. So 60 times the cosine of 65 gives us an x speed of 49.1 meters per second. Similarly, let's go ahead, 60 times the sine of 65 gives us a y component equal to 54.4. All right, so we've got the x and y components of the speed. Let me try that one more time. So 49. All right, so let me just try this one more time. So 60 times the cosine of 65. Sorry, I knew there was something wrong with this. Let me just correct this right here. So 60 times the cosine of 65, that speed is actually 25.4 meters per second. And so that gives us a better calculation, a more accurate calculation. Yes. All right. Now that we've got these two components, we can just go ahead and use them in our equation here. So we want the maximum height reached, the time it spends in the air, and the horizontal range it covers. So the maximum height it reaches is s, by the way. The time it spends in the air, we'll take a look at that in a second. And the horizontal range it covers is this number x right here. So x naught is 0 always. X is unknown. Ux is the x component here, which is 25.4. Our time is unknown. S is the height. We don't know what that is. Uy is the initial vertical component of the velocity. That's 54.4 meters per second. Let me put some units here just so we're good. We don't know what v in the vertical direction is. We know the acceleration is 10 meters per second squared. We don't know the time it spends going up. But actually, we do know this. V at the very top is 0. So I'm going to write v is 0 at the top. And so we're going to use that to actually solve something. So first, let's get the height reached. So using the formula, we have s equals -1/2 at squared plus uy times t. And if we actually look at this here, we don't know the time, and we don't know uy. So for part A, this formula is actually not going to work. Let's try the third formula then. So we can say vy squared, and I should label it more carefully. I should call this vy, and I'll call it that here and here, just so that we know we're talking about the vertical direction. That's why. Equals uy squared minus 2 times a times our unknown s. So we have a speed of 0 at the top is 54.4 squared minus, and we're going to put 10 in for g, so that's minus 20 times s. Now I'm going to skip some algebra here. When we solve for s, we're going to end up getting sorry, let me just do this now. It's going to be 54.4 times 54.4, and then we're going to divide that by 20, and that's going to give us 148 meters up into the air. Now for part B, let's use Vy equals negative AT plus Uy. And here's what we're going to say. At the top, Vy is 0. So that's going to give us 0 equals negative 10 times t plus Uy, which is 54.4. And so this is going to give us the time to go up to the top. So let's subtract 54.4 from both sides. And so we're going to end up getting t is 5.44. So here's the height. And this is just to go halfway up. So the total time is 2 times 5.44, which is going to give us 10.88. All right. And then for part C, let's go ahead and get the horizontal range to cover. So that's going to be x is uxt plus x naught. Oh, that's gross. Let me try to rewrite that again. So x equals uxt plus x naught. So that's x equals 25.4 times the total time, which is 10.88 plus 0. So x equals 276.4 meters. So there's our horizontal range. All right, so that takes care of problem number 8, and I'm going to post these videos in Haiku so that you have them available.